A helicopter rises with a constant velocity of 20 meters per second. At a height of 120 meters above the ground, a package is released. How long does it take the package to reach the ground? Let's first take a look at this helicopter. The helicopter rises at a constant velocity, releases the package about there, which continues upwards for a little while and then falls back to the ground. The distance that the helicopter is above the ground when it releases the package is 120 meters. Other information that we're given is that the velocity of the helicopter, and hence the velocity of the package when it is released, is 20 meters per second upwards. The question in the problem is how long does it take for that package to hit the ground? Alright, that is the problem. Try to work on that solution before watching the solution. Here is our problem. We're told that the initial velocity of the helicopter and hence the package is 20 meters per second. I've labeled that at that time, t equals 0, the initial displacement is 0. Sometime t later, the displacement is minus 120 meters. We want to find out what that time is when the displacement is minus 120 meters. All right, that's our problem. If we look at our favorite equation here, y is equal to y0 plus v0t plus 1/2 gt squared, and substitute the values in that we have, that y is minus 120 meters. I'll dispense with the units to save a little space here, is 0 plus 20 times t plus 1/2 g, which is minus 9.8 times t squared. And that can be rewritten. Minus 120 is equal to 20t minus 4.9 t squared. And if I put all the terms on one side, on the left side of the equation, bringing the minus 4.9 t squared over, it becomes positive. 20t becomes minus 20t and minus 120, that all of this is equal to 0. This is a quadratic equation, and the solution to the equation of the form ax squared plus bx plus c equals 0 is x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. We'd like to apply that equation to our particular equation. If I identify the a with the 4.9 and the b with the minus 20 and the c with the minus 120, then we can write that t, our variable, is minus b, which is plus 20, plus or minus the square root of b squared, that's minus 20 squared, minus 4 times a, which is 4.9, times c, which is minus 120. And continuing with that, all divided by 2 times a, which is 2 times 4.9. And we can write that that is t is equal to 20 plus or minus the square root of 20 squared, that is 400. And then these quantities multiplied out give you 2352. And divide all that by 2 times 4.9, which is 9.8. And you'll come up with 20 plus or minus, when you take the square root, 52.5 when it's rounded to 3 places, divided by 9.8. And if I take the plus 52.5, this then is 72.5 divided by 9.8, and that gives me about 7.39 seconds rounded to 3 places. So that's the time that it takes for the package to hit the ground. All right. That's the solution to our problem, and that is our last problem.